So let's welcome in next lecture of MAT-201, that is integral calculus. So in previous lecture we have seen the formula to find integration of sin raised to nx dx from 0 to pi by 2. So in this lecture we will see the reduction formula for integration of cos raised to nx dx. So case 1, if n is an odd positive integer, say suppose it is 2k plus 1. So in this case we can write integration of cos raised to nx dx as cos raised to 2k plus 1 x dx. So you can write this cos 2k plus 1 as cos raised to 2k into cos x dx. So here, so cos raised to 2kx, you can write cos square x its power k into cos x. So if you put suppose cos square x equal to 1 minus sin square x, so it becomes, that is integration of 1 minus sin square x its power k into cos x dx. So here we are making one substitution, that is we are putting sin x equal to t. So if you put sin x equal to t, so it implies cos x dx equal to dt. So you can replace, so resulting integration becomes, that is integration from 1 minus t square its power k dt. So in this integration, so this term 1 minus t square its power k can be expanded using binomial theorem. And if we expand this term using binomial theorem, and we can take its integration with respect to t, so which is the usual integration. So after integrating it, you can resubstitute the value of t, that is cos x, so that will give us the required integration of cos raised to nx dx. So this is in the case when n is an odd integer. So uh, we can evaluate one particular integration, that is integration of cos cube x dx. So here, so n is equal to 3, and which is odd integer, you can write this odd integer as 2 into 1 plus 1, that is k equal to 1. So here the value of k is 1. So we can write this integration, that is integration cos cube x dx as 1 minus t square its power k. So here is no need to use binomial theorem, its power is 1. So it is integration of 1 minus integration of t square. So it gives t minus t cube upon 3. So after resubstituting value of t, that is sin x, so you'll get the resulting integration, that is sin x minus sin cube x divided by 3. So this is the value of integration of cos cube x dx. So that is first case. What is second case? So second case, that is when n is an even positive integer. So in that case you have to use reduction formulas. First you have to derive the reduction formula for this integration cos raised to nx dx. So for that, let us put suppose I equal to integration of cos raised to nx dx. So you can write this term, this power of cos, that is n. You can split this power n as n minus 1 plus 1. So you can write n as, so here you can write n as n minus 1 plus 1. And so it gives us cos raised to nx dx as cos raised to n minus 1x into cos x dx. So here you can use integration by part, and after using integration by part, so here you can consider suppose cos raised to n minus 1x as u function, and and cos x as v function. So after using integration by part, so this integration will be cos raised to n minus 1x into sin x minus, that is, so here integration of cos x, that is sin x, and cos raised to n minus 1, we take it as first term, so it remains as it is. So minus big integration, in that is, so derivative of first term, that is cos raised to n minus 1x, so it will be n minus 1 cos raised to n minus 2 x into derivative of cos x, that is minus sin x, into uh, yeah. So first term, so derivative of cos x, that is minus sin x, and so here what is the integration of cos x? So it is sin x. So we take it as it. So next, so if you collect these two terms, that is sin x and minus sin x and sin x. So you can take this minus outside of this integration. So this minus will be plus. So n minus 1 you can take outside of integration. So it will be integration of sin square x into cos raised to n minus 2 x dx. So you can put value of sin square x, that is 1 minus cos square x, and you can split this term of integration. So you'll get, see, yeah. So it will be n minus 1 integration of cos raised to n minus 2 x dx, and minus, so this minus you can take outside of integration, minus n minus 1, so integration of, so cos square x and cos raised to n minus 2x, so it will be cos raised to nx. Just a minute, what happens, yeah. So it will be cos raised to nx dx. So this integration, that is integration of cos raised to nx dx, is nothing but I, and this value is equal to I. So you can transfer this term to left hand side, so it will be I equal to, so you can write this integration as integration I equal to, that is cos raised to n minus 1x into sin x plus, so n minus 1, so integration cos raised to n minus 2 x dx, and it will be minus n minus 1 into I. So you can transfer this term to left hand side, so it will be, so you can write it I plus n minus 1 into I, and that is equal to cos raised to n minus 1 x into sin x plus, so it will be n minus 1 into integration cos its power n minus 2x dx. So this term I plus n minus 1 into I, so it is nothing but just ni. So you can divide whole equation by n, so it implies cos raised to n minus 1x into sin x whole divided by n plus, so it will be n minus 1 divided by n, and it is integration of cos raised to n minus 2 x dx. So here, yeah, sorry, so I'm dividing it by n, yeah. So resulting integration will be, so it will imply I, that is integration of cos raised to nx dx, and this integration will be, so after dividing both sides by n, so you will get, that is cos raised to n minus 1x sin x whole divided by n plus, that is n minus 1 divided by n, and it is integration of cos raised to n minus 2 x dx. So this is the required reduction formula in the case when n is an even integer. So you can write the formula for integration of cos raised to nx dx when n is an even integer. So we'll see some illustrative example on this. So let's take one example. Evaluate what happens. evaluate the integration of cos raised to 6x dx. So here, what is the value of n? So n is equal to 6, and which is even integer. So we can use this reduction formula. So using this reduction formula, you can find the value of this integration. So solution. So here n equal to 6. So which is an even integer. So therefore, you can use the reduction formula. So here, so we have reduction formula, that is, what is the integration of cos raised to nx dx? So it is nothing but, see, so cos raised to n minus 1x into sin x whole divided by n plus n minus 1 divided by n. So it is integration of cos raised to n minus 2 x dx. So you can write this equation as suppose equation number 1. So here, first put n equal to 6. So put n equal to 6 in 1. So we get the integration of cos raised to 6x dx will be equal to, that is, so cos raised to 5x into sin x whole divided by 6. So we are putting n equal to 6 plus, that is, 5 by 6, and it is integration of cos raised to 4x dx. So you can write this equation as suppose equation number 2. So again, you can find this integration, that is integration of cos raised to 4x dx, using same reduction formula, but you have to put here n equal to 4. So that will imply, so again put, so n equal to 4 in 1. So yeah, we get the integration of cos raised to 4x dx. So it will be, that is, cos raised to 3x into sin x whole divided by 4. So here we are putting n equal to 4, so it will be plus 3 by 4 integration of, so cos square x dx. So you can write this equation as suppose equation number 3. So again, so we have to find this integration. To find integration of cos raised to 6x, you have to find integration of cos raised to 4x, and to find integration of cos raised to 4x, you have to find integration of cos square x. So to find integration of cos square x, so you have to put n equal to 2 in equation number 1. So it will give us. So finally, put n equal to 2 in a reduction formula 1, or you can write equation number 1. In equation 1, so we get, or we have, so integration of cos square x dx will be equal to, that is, cos x into sin x whole divided by 2 plus, that will be half, and it is integration of just, so cos raised to 0x, so it will be just 1, so dx. Or further you can write this as, so it will be it is equal to cos x into sin x whole divided by 2 plus x by 2. So you can write this equation as suppose equation number, what is that, 4. So you can resubstitute. So values of equations 4, 3 in 2. So we'll get, so resubstituting, equation 4 in equation 3. So what we get, so we have, see, the value of integration of cos raised to 4x dx will be equal to, that is, cos cube x into sin x whole divided by 4 plus, so it is 3 by 4. I am putting here value of integration, that is cos square x. So it will be, so cos x into sin x divided by 2 plus x by 2. Or you can multiply, or you can take this half outside of this integration. So it will be, so you can write in simplified form. So it will be, let us see, cos cube x into sin x whole divided by 4 plus, so it will be 3 cos x into sin x whole divided by 8 plus, that is 3x divided by 8. You can write this equation as suppose equation number 5. So you can substitute equation number 5 in equation number 2. So you'll get, see, you'll get the required integration. So next, see, substituting equation 5 in equation 2. So we get the value of integration cos cube x, sorry, cos raised to 6x dx. So it will be, that is cos raised to 5x into sin x whole divided by 6 plus 5 by 6, and the value of this integration. So what is that? So it will be cos cube x into sin x. So it is divided by 4 plus, it will be 3 sin x into cos x. So it's divided by 8 and plus last term, that is 3x divided by 8. So you can simplify it. So it will be, this cos raised to 5x into sin x whole divided by 6 plus, it will be 5 cos cube x into sin x divided by 24 plus 15 sin x into cos x whole divided by 48 plus, it will be 15x divided by 48. So this will be the required value of integration. Yeah. So this is the required answer we can write. So this is the, yeah, integration of cos raised to nx dx if n is an even integer. So already we have seen first case, that is if n is an odd integer. So in that case, so you have to use binomial theorem to derive the integration of cos raised to nx dx, and you have to put n equal to 2k plus 1. So you have to write n in terms of 2k plus 1, and then you have to use that k to expand or to use binomial theorem. So this is about integration of cos raised to nx dx. So I will give, yeah, the homework on this type, and in next lecture, so we will see the formula for integration of cos raised to nx dx from 0 to pi by 2. So before that, so I will give some problems as homework, so you can solve these problems. Homework. So evaluate the following integrals. Yeah. First, integration of cos raised to 5x dx. Second, integration of suppose cos raised to 7x dx. Third, integration of cos raised to 9x dx. Fourth, integration of suppose cos raised to 11x dx. Fifth, integration of suppose sine cube x. Sorry, I'm taking sine cube. Integration of cos raised to 4x dx. Then, yeah, integration of suppose cos raised to 8x dx. Then integration of cos raised to 10x dx. And last, you can find integration of cos raised to 12x dx. So solve these problems